Hey YouTube, Never-Ending Student back for a second video on this Agilent 6672A power supply. I just realized no one else has a video on this specific model, so I thought while I have it on the bench and while I still have possession of it before I sell it off, I'd get some characteristics and behavior recorded in case anyone else is trying to look this up and see, hey, this weird thing it's doing, is that happening to someone else? So, disclaimer, for all I know, this has specific programming in it that was put in by GPIB, or possibly just my lack of knowledge for how to interact with the front panel, and there's stuff going on with this that I just don't know how to change. So, be aware, I don't know everything. So, let's unscrew this. So right now, I have this current limited to 1 amp. So my voltage is set to 5 volts, my current is set to 1 amp. And you can see it's only at like 136 millivolts. That's because I have my load active, and my load's trying to draw 2.4 amps. It is successfully current limiting to 1 amp, as it should be. It's slightly off because it's at local sensing. And let's get a view of that. This was removed from wherever it was installed, and the sense terminals weren't connected. So maybe they had remote sensing, maybe they were doing something by GPIB interface, I'm not sure. But if you need to set up local sensing, so there's the two small screw terminals down there, and then you have two terminals there. There's S plus and S minus, and LS, I think LS plus and LS minus, or let's find out. Do I still have the... Yeah, okay. So, in the user manual, right there, so those two screw terminals are negative LS and positive LS, and then your actual sense terminals are the bottom two on that little screw terminal connector. The second from the bottom is sense positive, and the bottom is sense negative. So for local sensing, you bridge sense positive to local sense, sense negative to local sense, or local sense negative. And if you want to do remote, from what I understand, you don't use these. You use these. So something to be aware of. That you can find in the user manual, but again, I didn't see any video on this specific model, so I thought I'd get some characteristics. Now, let's turn off load. And that jumped back to 4.999. Very nice. So, you can't really make that out at the same time as that or here. Enter. So right now it says correctly 5 volts and basically no current. We're on 5 volts, no load. We're going to turn the load down. Alright, so it's limited to 1 amp. We're going to ask for 0.9 amps. Load. We drop down to 4.81 volts over here. There's more wire distance to get to this, so that makes sense. 4.919 there. And we still show 5 there, which makes sense. The closer you are to where sense is actually connected, the closer you get to, it's going to output what it's being told to output as it measures it there. So once you add in all the wire resistance to go through the wiring I have set up here, then yeah. So the lower voltage does make sense electrically. Now, with current limit, well, here, let's do it this, no, we can do it this way first. So right now, we're on 0.9 amps, and that power supply is set to only put out 1 amp. Watch what happens. And this is actual current draw right here. We're drawing more than an amp. 1.2. Okay, there. So, as far as I can tell, that isn't just a matter of going to a certain percent over and then limiting. So let's go down. So now we're back at 5 volts. So let's go up close. We'll go to 0.9. Alright, so we're at 0.9. Now I'm going to spike it up really fast. 2.68 amps. And it's giving that amperage, there you go, for about 4 seconds. That's what I've been seeing consistently. Drop it back down. It's back to 5 volts. Now we're at 1.02 amps. So we're drawing a teeny bit more. And it's not limiting. Let's go to 1.1 amps. It's allowing 1.1 or 1.80 or 0.82, and it's not dropping it down. So this is the behavior I've been seeing. I think it's the amount of percent tolerances that it's allowing. Because it does accurately read that it is supplying 1.08 amps. So it's not like this doesn't know. It's not like it's incorrectly reading current. It's reading it correctly. So I'm seeing a behavior out of this power supply of, oh, there, we just saw it happen. It dropped down to 1 amp. So time seems variable. We asked a little bit more than 1 amp, and it gave us that little bit more than 1 amp for much longer than when we asked for like 2.6 amps. So there seems to be some kind of profile setup, or maybe it's some kind of, I really don't know. But I wanted to document the behavior. There seems to be a relationship between allowed time for overcurrent and degree of overcurrent. So let's try changing it up. So right now our voltage is at 5. We'll leave it like that. Let's go to current. Let's go to 2. It popped right back up to 5. There's no wait time. I don't have overcurrent protection. I have that disabled. Now, just for funsies, let's go current 1.0 and overcurrent protect. So now there's a little caret there, so overcurrent protect. We see that we're drawing 1.08 amps, so slightly more than what we're supposed to. That took a while last time for it to trip. It's like a slow blow fuse kind of behavior. So let's go to current and tell it I only want to deliver half an amp. Overcurrent protection is active. Okay, you just saw it happen. So 4 or 5 seconds, something like that. And I'm guessing that's the minimum time. Again, it's quite possible this is a behavior that was programmed in by GPIB. I don't know if it's something you can do through the front panel. You can do a lot through GPIB. You can tell it to do really complex things that way. So let's go turn off current protection, shift, clear protection, and then current, let's go 2 amps. So now we're going to check and see if we increase the current, is that going to change the time profile between when we ask for much more current and when it goes into either limiting or protection mode. So right now protection is off. So if the behavior stays the same, again, we're set to limit to 2 amps right now instead of 1. If the behavior stays the same, when I sharply dial the load up and ask for like 3 or 4 amps, we should see a approximately 4-second pause before it shuts down or limits. So let's go asking for 5 amps. It's giving us 5 amps. Okay, that happened much faster than 4 seconds. So it does look like it is on a curve of the amount of overage versus time. Let's go back to 1.6. So again, we're currently allowing 2 amps. So let's ask for 2.2. And it's giving us 2.2. Again, it's limited to 2. And we just saw, okay, voltage, yep, there we go. You saw voltage gradually reduce until it was able to go to 2. And it took a lot longer, so yeah, it's currently either default behavior on the 6672A is to have that relationship between time after current exceeded limit and when it dials it down or engages protection, or it's something programmed into this specifically. I apologize for not having a better answer as to why for certain this model exhibits this behavior. This is more just documenting how this is behaving, just as reference for other people on the internet if they want to look up this unit. So let's go, what else can we get on this? Let's go to overcurrent protection. Actually, no, let's disable that. Clear. Let's go current, 5 amps. Actually, I'm connected by alligator clips just grabbed on, not bolts, so maybe I don't want to do that. I certainly wouldn't try for 100, obviously not with that. No, but we can go a little bit more, so let's go for 3 amps. Alright, so again, I'm going to try to turn it up sharply. Seven amp, okay, and then it dropped down. Oh yeah, that's something else we can benchmark. Alright, so I brought it back down to just under 0.9 amps. I'm going to change this now to limit at 1 amp. Okay, so current, now I have it changed to 1 amp. And I'm curious if I ramp this up really fast, just how high it will spike. Actually, we can do that like this. I'm going to try to draw 10 amps. So no fiddling with how fast can I spin the dial. And let's keep an eye on that amps and see if it even momentarily actually delivers. Yes. Oh. It was for a fraction of a second, but it did. $19 amps. We're getting spicy now, at least for my wiring, but it's momentary. And yes, another fraction of a second, and even less than last time. So yeah, it does look like it's on a kind of relational curve between time and overcurrent. Oh, and before I knew about how to properly connect the sense terminals, I was getting, let's see, without the sense terminals connected at all, and if they're local, they're supposed to be connected by local as I have it right now as default. It'll still give you power without that, but with no sense at all, it was pretty inaccurate by like a couple hundred millivolts. So instead of this beautiful 4.999 volts, I was getting, what was it? It was 4.8 something. And then I had kind of larger shifts under load before current limiting. And then when I had the sense terminals connected into this wired juncture, of course I had less fluctuation here because there was less wire distance between the sense connection and here. So yeah, if you don't have the sense terminals in that little screw terminal block connected to anything, it will come across as being inaccurate. You might think, oh, well, this just needs to be calibrated. It can be deceptive or just complicated if you haven't read through the 150-page user manual. You might be looking at local and thinking, oh, local sense, there we go, yeah. But no, it's external terminals. It doesn't have, as far as I can tell, like internal terminals that it can just say, okay, I'm going to relay to those, and by default sense that without having to physically connect something. You do have to connect those for accurate results. All right, that's everything I can think to do with this. I'm not going to be tearing it down since it is operational and it's about to be sold. So yeah, that's it. Have a good day.